So we've learned that atoms are a thing, electrons are a thing. Now we're going to find out how the nucleus was discovered. And so, up to now, we know that charged particles exist, but scientists already knew that atoms weren't negatively charged, they were neutral. So, what does that suggest? Well, it suggests that there's a positive charge somewhere in the atom. So, J.J. Thomson, the guy who discovered the electron, he thought that, well, the atom must look like something like that, where we have electrons and it's in this field of positively charged sphere, and we call it the plum pudding model. Now, scientists wanted to confirm these models, and so we could start to look at what atoms actually look like thanks to radioactivity, which was discovered by Henry Becquerel and Marie Curie. Now, Rutherford in 1909, he's one who actually used this radiation to try and see, okay, are atoms really this sphere of positive charge, and inside this charge are negative electrons? And the reason he thought that plum pudding was right was that because J.J. Thomson was his mentor. So he thought, oh, he couldn't be right. I work for him. So he had this neat, he being Rutherford, had this neat experiment. He would have a source of radiation, and he would shoot it at this gold foil. So alpha particles are a type of radiation that we'll talk about at some point in this course. Now, around this gold foil, he would have some kind of detector. Think of like film that can detect this. And you would just see, okay, when I shoot this radiation at this gold foil, how do the particles deflect? So we had two different ways they could reflect. And the plum pudding model, since it's just a sphere of positive charge and electrons are so tiny, we thought, okay, shoot radiation, it should go right through the gold foil and it should not deflect at all. But that is not what Rutherford saw. Rutherford saw a lot of the beams actually go through without deflecting, but some of the beams have a very large deflection, which means when the particles are going to the gold foil, they're hitting something. And when they hit that something, they deflect off. We know that something now to be the nucleus, but at the time, they didn't really know what was hitting these alpha particles. And so Rutherford proposed that the atom actually isn't this sphere of positive charge, but he thought that there's a nucleus in an atom. And this is called nuclear theory, which has three parts that you want to know. The first part of nuclear theory is that one, most of the atom's mass and its positive charge are in the small core of the atom, which is called the nucleus. 2. Most of the volume of the atom is just pure empty space. And in this empty space, we have these tiny negative charge electrons that are zipping through, and they're dispersed. And 3, the amount of negatively charged electrons outside the nucleus and the number of protons inside the nucleus are the same, making the atom electrically neutral. So those are the three parts of nuclear theory that Rutherford proposed. And Rutherford's model actually matches well with experiments, but there were some flaws. So, for example, hydrogen has one proton. Helium has two protons. But if you weigh hydrogen, it's only 1/4 the mass of helium, which doesn't make sense if you think only protons are in the nucleus. Well, that problem was solved by James Chadwick. And he saw that the reason why hydrogen is 1/4 the mass of helium is because there's another particle in the nucleus which doesn't have a charge, so it's neutral, so we call them neutrons. So this is the view of the atom as we know it today. 99.9% of the mass of an atom is in the nucleus with the protons and neutrons. But the nucleus is super tiny and really doesn't take up much mass. Most of the atom is empty space, and in this empty space are electrons. And so how far are the electrons from the nucleus? So imagine that this period is the nucleus. The nearest electron to this period would be 10 meters away. So that just gives you some scope as to how empty atoms usually are. And we go back to Rutherford's experiment, that's why most particles went through the space and didn't deflect because they weren't hitting anything. But few of those particles did hit the nucleus and were deflected a lot. All right, that's all we have for nuclear theory, and I'll see you in the next video.